Hi everyone! Many devices from dishwashers to military drones and defense systems use conformal coatings to protect printed circuit boards from moisture and other environmental effects. How to apply the coating so that it does not crack in the cold and does not peel off after a month. I will talk about PCB preparation, coating application methods, common mistakes, and what's actually worth using in the practice. I will explain why even a good coating can fail if the PCBs is not properly prepared or the coating is not applied correctly. Part 1. What is electronic moisture protection and why is it needed? Moisture protection is the application of an insulating coating layer to a printed circuit board. The purpose is to prevent aggressive environmental conditions and moisture from affecting the operation of electronic components and to extend the life cycle of the device. In addition to coating the PCB, sealants are also used to completely encapsulate the enclosure containing the PCB. A clear example is electronic control unit in vehicles, but this is a more complex option. Coatings are easy to apply and allow fast processing of large batches. However, sometimes full encapsulation is strictly required. Full encapsulation serves to fix components in place, especially heavy ones that can detach due to vibration or mechanical shock. For example, in vehicles, aerospace systems, or industrial equipment. Potting with compound prevent this and also protect the device from moisture and environmental exposure. Part 2. Key principles of working with moisture protection coatings. Air bubbles in the layer are a defect. If air bubbles remains after coatings, protective properties are reduced. Moisture can be trapped in the bubbles, which may freeze in negative Celsius temperatures and cause cracks inside the layer. Bubbles are removed using a vacuum chamber or by dipping the PCB into a very fluid coating. Use solvents recommended by coating manufacturer. Second, thick coating is not always good. You should not apply more than 2 layers of coating. When the coating is too thick, it loses strength during rapid temperature changes from negative to positive and back. Every coating has a thermal expansion coefficient, and thick layers can crack and even damage or detach components. Ideal when applied 2 thin layers with proper drying in between. Third, test PCBs with coating in a thermal chamber if possible. Even one properly applied layer can crack at minus 65 degrees of the Celsius or minus 85 degrees of Fahrenheit. If the device is critical, test coated PCBs in a thermal chamber. I have performed such tests. The thick layer cracked while the thin layer remained intact and protected the PCB. Before I will going forward, pause this video, like it and subscribe to my YouTube channel. Thank you so much. Fourth, never apply coating on the dirty PCBs. Before apply coating, PCBs must be cleaned in a professional cleaning system. Residues of any soldering fluxes and other contaminants interfere with adhesion, which over time can cause the coating to peel. Adhesion is the bonding properties between different materials. Fifth, always work under a fume hood, not just a filter. Use a proper fume hood designed for this work, ducted chemical fume hood. The hood should have a dedicated exhaust duct to the outside, and the ventilation system should ensure fresh air supply to maintain air balance. 6. Coating behavior at low temperatures. If the PCB operates in freezing condition, it's better not to use the deep coating method, as the coating may shrink in the cold and damage solder joints by pulling on and detaching components. But at high temperatures, the coating can soften or melt. This also needs to be considered. 7th, spot mask for protection connectors. Connectors and some contact pads must be protected, taped off or covered with a spot mask. A spot mask is a gel that's inert to metals and becomes rubbery, allowing the coating to be applied and then the spot mask removed, leaving components cleaned. I recommend testing the spot mask on the connector first before applying moisture protection. There have been cases where the spot mask reacted with the connector metal and caused oxidation on surfaces. In such cases, find a different spot mask. 8. Read IPC standards. The IPC-CC-830 standard defines requirements for conformal coating, while IPC-TM-650 include testing methods such as adhesion and thermal cycling. These documents form the basis for the protection of electronics. Part 3 of this video, methods of applying moisture protection coating. Methods 1. Applying conformal coating with the brush. The simplest method. Bubbles are common. One issue is that brush bristles can fall out and get stuck in the coating layer, making them hard to remove. Method 2. Fully dipping the PCB in coating. The coating should be very fluid, like water, to ensure an optimal thin layer. The board is fully submerged in the coating for about 1 minute. During this time, the coating flows under the component and displaces air. After remove, allow the coating to drip back into the container. Boards are dried vertically on hooks in the fume hood or in a specially designed drying system. Method 3. Robotic conformal coating application. The fastest and most precise method using in PCB productions. Robot apply the coating only to specific areas, avoiding accidental contact with connectors and places that should be without varnish. Method 4. Spray can or manual sprayer. A fast and convenient method for small batches and post-repair protection. The varnish coating is applied quickly, multiple layers can be added, but it's difficult to control uniformity. Part 4 of this video – solvents for varnish. Each type of conformal coating, acrylic, silicone, urethane or epoxy, requires its own solvent, listed in the datasheet, on the sticker or on the manufacturer website. Don't use random solvents. This may cause separation, poor adhesion or incomplete curing. You will just ruin the varnish. In conclusion, properly applied conformal coating is not a small thing. It's what ensures your PCB doesn't fail due to condensation, moisture, cold or dust. It's especially important for critical electronic devices. Like this video and subscribe to my YouTube channel. Leave any comment for promote this video in YouTube. I provide consulting and PCB repair services for electronic manufacturers. In description on this video you can find links to my soldering fluxes, diamond flux, Instagram and Telegram group. Thank you for watching. See you next time.